So in the second order system, so this is the equation omega n squared over s square plus 2 zeta omega n into s. It is a standard equation, unity feedback system and negative feedback system. And if we simplify, if we find out it's a transfer function, then you will get c of s divided by r of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square, where omega n is natural frequency and zeta is the damping ratio. We studied that one. In the previous video, we studied four conditions also. Undamped system means zeta is equal to 0. Underdamped system means zeta is between 0 and 1. Critically damped means zeta is 1. Overdamped means zeta is greater than 1. Now we'll try to find out the characteristic equation of second order system. So that is characteristic equation of second order system. We'll take a denominator s square plus 2 zeta omega n s plus omega n square equal to 0. How to find out the characteristic equation? We know that basic formula x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. This formula we will use to find out the characteristic roots of this characteristic equation. So where a is equal to 1 plus b means it is coefficient of s, that is 2 zeta omega n, and c is a constant, that is omega n square. So we'll substitute here. We want x means we want s. S is equal to minus b means minus b. Yeah, b means 2 zeta omega n. So we just substitute minus b. It is 2 zeta omega n plus or minus square root of b square. B square means b is 2 zeta omega n square minus 4 into a. A is 1 into c. C is omega n square. So minus 4 into omega n square divided by 2 into a. So a is 1 divided by, so divided by 2. Next, simplify. Because it is a second order system, we will get two characteristic root of characteristic equation. Two roots we will get. So that's why I will write s1 comma s2. It is equal to minus 2 zeta omega n plus or minus square root of, we just simplify this one, 2 square, it is 4 zeta square omega n square minus 4 into omega n square divided by 2. So then again s1 comma s2 equal to minus 2 zeta omega n plus or minus. So I take here also in within the square root to 4 zeta square omega n square minus 4 omega n square. So 4 is a common term and omega n square is a common term. So I will take 4 omega n square outside, out from this square root term. So that is, if you take outside, then it is 2 into omega n. The square root of zeta square minus 1 will be remaining divided by 2. So now, if I take, see in this equation, 2 is common in the numerator, minus 2 zeta omega n plus or minus 2 omega n square root of zeta square minus 1. So I can take 2 outside and denominator also 2. So I can cancel 2. So then finally you will get s1 comma s2 is equal to minus zeta omega n plus or minus omega n square root of zeta square minus 1. So now for different value of zeta, we'll find out the root. We'll see what value of s1 and s2 we'll get for second order system. First, we'll substitute when zeta is equal to 0 for undamped system. For zeta is equal to 0, if you substitute zeta is equal to 0 here in this equation, if you substitute zeta is equal to 0, then we'll get s1 comma s2 is equal to plus or minus omega n square root of minus 1 we'll get. If zeta is equal to 0, first term will be 0 plus or minus, here zeta square is 0. So square root of minus 1. We know that square root of minus 1 is minus, square root of minus 1 is a j. So if I substitute that j here, then s1 comma s2 is equal to plus or minus j into omega n. So then roots are, if zeta is equal to 0, then roots are purely imaginary and the system is undamped system. So because it is plus or minus j into omega n, so it's purely imaginary, no real terms. So when zeta is equal to 1, when zeta is equal to 1, we have to substitute in this equation. When zeta is equal to 1, we will get s1 comma s2 is equal to minus omega n and plus or minus 0. So finally s1 comma s2 is equal to minus omega n. So we can say that it is roots are real because there is no j term. So roots are real and equal because s1 comma s2 is equal to minus omega n. Both values are same. So system is critically damped. Next function is when zeta is equal to zeta is greater than 1. Then s1 comma s2, how to find out s1 comma s2? So that is s1 comma s2 is equal to minus zeta omega n plus or minus omega n square root of zeta square minus 1 we know equal to minus zeta omega n plus or minus omega n. So some simplification we have to do here. I'll take minus 1 outside. So minus 1 into 1 minus zeta square we can write. So then it is minus zeta omega n plus or minus omega 1 omega n. So I will take this minus 1 square root term, I will write separately, and square root of 1 minus zeta square I will write separately. So it is I will get s1 comma s2 is equal to minus zeta omega n plus or minus j into omega n. So I can finally write roots are complex conjugate and the system is under damped. So here I am going to write this omega d is equal to omega n into square root of 1 minus zeta square. Omega n into square root of 1 minus zeta square is omega d. I am representing this omega n into square root of 1 minus zeta square as omega d. So for zeta is for the system is under damped. So next we'll see response of undamped system for unit step input.